Okay, grade 8. We are doing this lesson over here, rhombi and squares. Okay, that's what we're going to do. Lesson 5, chapter 11. Okay. All right. So we start rhombi and squares. One is called rhombus. More than one is called rhombi. So 2 and more rhombi. One is called square, more than one is squares. Okay? Now, you need to know that these two polygons belong to quadrilaterals. So, I started by explaining what are quadrilaterals. You have 4 sides. And how many quadrilaterals do we know? 6 of them. Parallelogram, rhombus, square, rectangle, trapezoid, and kite. Now, I wanted us to compare quadrilaterals, so you need to so that you can understand what is the relationship between rhombi and squares. So we compare things, polygons that are parallelograms only. So no. We compare quadrilaterals that are parallelograms only, and quadrilaterals that are non-parallelograms only. And then here in the middle, we need to say what makes what is the same, what is the similarity. So this is the similarity, these are the differences. Okay, so parallelograms only, there are 4 parallelograms: the square, the rhombus, the rectangle, and the parallelogram. Why? Because opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, diagonals bisect, 2 triangles are congruent. Now, non-parallelograms, the kite and the trapezoid, there are 2 quadrilaterals that are non-parallelograms because opposite sides are not congruent, opposite angles are not congruent, opposite sides are not parallel, diagonals do not bisect, 2 triangles are not congruent. Now, what is the same for parallelograms and non-parallelograms? What am I saying? What is the same about these six quadrilaterals? Okay? Now, both of them must have 4 sides. All of them. All of them must have 4 interior angles because they belong to the quadrilaterals. All of them, the interior angles must add to 360. All of them, all the angles that are exterior must add to 360. The consecutive interior angles must be supplementary. This rule should be for all 6 of them, not just the parallelograms. The consecutive interior angle rule must be for all the 6 quadrilaterals. Now, there's something special about quadrilaterals. It is the only polygon whose interior angles add up to 360 and also the exterior angles add up to 360. The only polygon, the number that for the interior angle sum is the same number for the exterior angle sum. Okay? All right, we have finished comparing quadrilaterals. Now we want to compare rectangles. Okay? Now here we do rectangles only, and here we do non-rectangles, and then here we do both. Now, if you notice, whatever I wrote over here, some of them ended up here. Actually, all of them ended up here. All right, rectangles only. There is 2 types of rectangles: squares and rectangles. Those are the only 2 quadrilaterals that are rectangles. The rest are not rectangles. So parallelograms are not rectangles, rhombuses are not rectangles, trapezoids are not rectangles, and kites are not rectangles. Why? Why are square and rectangles the only type of quadrilaterals that are rectangles? Because they have 4 right angles, because their diagonals bisect, because the product of the slope of the length and the width must be -1. Okay? Now, what is the similarity between square, rectangles, and parallelograms, rhombus, trapezoid, and kite? They all have 4 sides. They have 4 interior angles. All the interior angles add up to 360. All the exterior angles add up to 360. Consecutive interior angles must be supplementary. Okay? We should add something here. The diagonals are congruent. Diagonals are congruent. Okay? For rectangles only. There. Why are these non-rectangles? They don't have 4 right angles. The product of the slope of the consecutive sides is not -1. These are the 2 reasons that make these not rectangles. Okay? Now we move on. Now, I want us to compare the square and the rhombi. So we are comparing the squares and the rhombi. So what is a square? A square is both a rectangle and a rhombus. Square belongs to 2 groups. Square belongs into rectangle and also belongs into rhombus. That is very important. Now, I should have started with rhombus, but it's okay. I start with the square. A square is a rectangle because it has 4 right angles and the product of the slopes of its consecutive sides is -1. A square is a rhombus because all its 4 sides are congruent. A square is also a quadrilateral. A square is also a parallelogram. So I wrote, so a square is a quadrilateral that is also a rectangle, a parallelogram, and a rhombus. That's what I just added these 3 statements together and I made one. Or I can say a square is a parallelogram that is both a rectangle and a rhombus. All these statements are correct. You should read carefully. The minute you read incorrectly, life becomes difficult. I keep saying that to you. Now, this is how a picture of a square looks. The congruent tick marks and the 4 right angles. When you draw a square, you must label it exactly like this. The letters must be different. The letters might be different, but these marks should be exactly the way you see them. Okay? So now let us discuss. Where did I write? Square. My paper has disappeared. Okay, here. All right, so I want to put both of them together. All right, so if I look at this shape, you have D, E, F, G. So what did I write? Angle D is equal or congruent, to angle E, which is congruent to angle F, which is congruent to angle G, because they are all congruent and all of them are 90 degrees. That's what I wrote over here. That is one important equation you should know about the square. Another important equation you should know is that angle MAB is half of angle DAB. So this angle right here, this one, is half of this angle, Why? Because the diagonals bisect each 90 degrees. Bisect means cut into 2 or multiply by 1/2. So that's what I wrote. Angle MAB is half of angle DAB. Half of DAB is 90 degrees. Half of means to multiply. I multiply this, I got 45 degrees. In a square, where the diagonals cut the angles, each angle will be congruent. Each angle must be 45 degrees. Must be. This is only in a square, not a rectangle, only in a square. I should see 45 degrees over there. If I see any other number, then that is incorrect. Okay? So, angle DAM and angle MAB are complementary because they must add to 90 degrees. Angle DAM, which is this one, right here, and angle MAB, which is this one, right here. These two angles are complementary because they must add up to 90 degrees. We said every corner is 90 degrees. And if you add up to 90 degrees, then you are complementary. Okay? Now, it says over here, where the two diagonals in a square intersect, where they meet, they form four right angles. So, this diagonal DBD and AC, they meet at M. All these four angles must be 90 degrees. They cannot be any other number. They must be 90 degrees. Okay? Now, we know that the diagonals are bisecting. So, you have this diagonal KI is congruent to HJ. Therefore, HR is the same as RJ. They are congruent. And KR is the same as RI. They are congruent. Therefore, you have four right isosceles triangles. Isosceles because you have two sides the same. Right because there is a 90-degree angle in each triangle. So you have a right angle, you have a right triangle because it has 90 degrees, and you have a right triangle that is isosceles because the base and the height are the same. The hypotenuse is different. The base and the height, so this will be your A, this will be your B, this is your C, if you are to label, because this is 90 degrees over here. So the base of the triangle and the height of the triangle are congruent. That is why we are saying in every square, the diagonals, when they bisect, they make four congruent right isosceles triangles. That's what we wrote over here. The bisecting diagonals create four right isosceles triangles that are also congruent. Now, because they have 90 degrees over here where they meet, that means diagonal HJ and diagonal IK are perpendicular. And how will you know they're perpendicular? Because they make 90-degree angle. They will ask you if they give you points. If HJ and KI are perpendicular, you should find their slopes. So that means you should find the slope of HJ and the slope of KI, and you multiply them. If you multiply these slopes and you get -1, then it means these two diagonals are perpendicular. If you don't get -1, it means they are not perpendicular, hence they are not a square. So if you multiply the slopes of the diagonals and you don't get -1, then that shape is not a square. You must get -1 for it to be a square. Okay? Now let us do rhombus. What is a rhombus? A quadrilateral, a parallelogram, because they have 4 congruent sides. Opposite angles are congruent. Consecutive angles are supplementary. All this is about a rhombus. The bisecting diagonal make 4 right angles at the point of intersection. This means the diagonals are perpendicular. You see 4 right, you should see perpendicular. Whenever you have a right angle, it means the two lines that make that angle, or the two rays that make that angle, must be perpendicular. Okay? What does perpendicular mean? You form 90-degree angle, and the slope of each line, when you multiply, you should get -1. If you multiply the two slopes of the two lines that make the 90-degree angle, you should get -1 always. If you don't get -1, then they are not perpendicular. Okay? So, I am saying the slope of AC, if it is 3 out of 5, then the slope of BD will be 5 out of 3 and then negative. So, let us see if these two numbers will give me -1. Okay? So, I have 3 over 5. I'm just saying, maybe you'll calculate and get something else. So let's say I calculated and I found my slope to be 3 over 5. Then I want to multiply with -5 over 3. Like that. And let's see what we get. So then I know my lines are perpendicular because I multiplied my slopes and I got -1. Okay? Now let us look at the pictures. So when you draw a rhombus, you should draw it like this. Okay? You should label. Now we said opposite angles are congruent. You see that? If you add m and n, you should get 180. M plus n equals 180 degrees. You should know that. N is equal to n, m is equal to m, like that. If you write 50 here, you should write 50 there, like that. Then you should know m plus n plus m plus n should give you 360. That's how you check your work. Now, we said the diagonals, they meet at 90 degrees there. You should have 90 degrees. Then you have four right triangles that are congruent. They are not isosceles. They are just 4 right triangles. 4 right triangles that are congruent. That's what this picture shows. This is my first triangle, which is the same as the second triangle, which is the same as the third triangle, which is the same as the fourth triangle. Why? Because if you look at L, let's put here what? Let's put here A. LAM, it is the same as MAN. Put the tick mark over here first. And put a tick mark over here. All right. If you look at each of these 4 triangles, they all look the same. They have 2 lines and 1 line and there. I should make this 3. 1, 2, 3, so that I don't confuse. All the 3 lines are different sizes. Okay? So you have a right triangle with 3 different sides. But each triangle is the same as the other. And they are right triangles. Now here, the one diagonal makes 2 isosceles triangles because the sides are congruent. So one diagonal makes 2 congruent isosceles triangles. Isosceles triangles. Okay? So this one diagonal cuts the rhombus into 2 equal parts, and this triangle is isosceles, and this triangle DBC is isosceles. Why? Because it has 2 sides that are the same. So remember, this side, all the sides are congruent in a rhombus. So these 2 are the same, therefore this is an isosceles triangle. Okay, then we continue. Now, we need to talk about these angles that are made by the diagonals. Okay, now, if you remember, this is a parallel line. Let me label. Let's call this A, B, C, D. Line AB is parallel to DC. So DB is a transversal. That means it cuts the parallel line. So A and A are interior alternate interior angles. And alternate interior angles from lesson 1 in chapter 5 in term 2 says alternate interior angles must be congruent. And remember, this is Z. See, this makes a Z. A, B, D, C makes a Z. So that this angle in the Z and this angle in the Z are congruent. So A is alternate to this A, B is alternate to this B, C is alternate to this C, and D is alternate to this D over here. Whatever number you write for D, you must write for this D on the opposite side of your transversal. So the diagonals are transversals in this picture. Whatever number you write for A is the same number you write for A here. Okay? Like that. Whatever number you write for B will be the same number you write for B. And remember, the diagonals bisect the angles. So A and B are the same number. A and B are the same. If you write 20 in B, you should write 20 in A. If you write 20 here, if you write 30 here, you should write 30 here. A and B will be the same. D and C will be the same. Okay? These angles are, it is just this big angle over here cut into two parts. Okay? All right. Now, another theorem you should know is if two consecutive sides, consecutive means if I start here, I should go here. Consecutive does not mean if I do this, I come here. No, that's opposite. Consecutive means one after the other. So GD is consecutive to DE, or GF is consecutive to FE, like that. So if one pair of the consecutive sides of a parallelogram are congruent, then that parallelogram must be a rhombus. The minute you put tick marks over here saying that they are correct, they are congruent, or they are the same, or if I wrote 5 centimeter here and 5 centimeter here, that means they are consecutive. Then that means that shape must be a rhombus. Must be. Okay? So, with that information, write down any questions you have. We will ask the questions tomorrow in class. I have very important questions to ask you. So please watch this video and watch Aleph video carefully. And listen to the Aleph video vocabulary. And listen to the vocabulary I am using. And also go through your book. These 3 things must go together. Must. You should be able to explain all of this. All. Okay? See you tomorrow. Do you okay? 1, 2, and 3.